Hey everyone, Math 103, we're working on section 3.4 today, solving general equations part 2. We're going to be looking at some equations that are more complex today, especially those that contain parentheses. Please take a look at the introduction. Suppose that you're saving for a down payment on a vehicle of $2,180. We have $750 saved so far, and we can save $65 a week. How long will it take us to purchase the vehicle? So these are the types of equations that we'll be able to solve today. Please start with a warm-up. Warm-up number one, we're simplifying. So we're going to combine like terms. Recall the like terms are those with the same variable part. So we're going to combine the x's together. 2x and 4x. So that is 6x. And now we're going to combine the constants together. -7 and 11. So that expression simplifies to 6x plus 4. Next up, we're going to simplify this expression. We've got some parentheses here, so we want to clear away those parentheses by distributing. 3 times 4 is 12, so we get 12x. 3 times -3 is -9. Now we're going to distribute -2 in. Remember that distributing a negative in changes the sign of all the terms inside the parentheses. So this positive is going to turn negative, so we get -10. And then -2 times -3 is +6, so plus 6x. And now this looks like the one from number one. We can combine like terms. So we've got 12x and 6x, that's 18x. -9 minus 10 is -19. So 18x minus 19. Next up, we're going to solve this one. We've got 3/5 x equals 9. We've got a fractional coefficient. We want to multiply by the reciprocal of that fraction, so 5/3. Flip that fraction over. 5 over 3 on both sides. Now over here, the 5's cancels, the 3 cancels, leaving us with just an x on the left. We got 9 times 5 is 45, divided by 3 is 15. So x equals 15. Now with this one, I always want to start by simplifying as much as possible. We've got some like terms on one side of the equation, so let's combine those. 3x plus x is 4x. So we got 4x plus 5 equals 29. Now we can subtract the constant from both sides, -5 minus 5. 4x equals 24. And we'll divide by the coefficient. We get x equals 6. Now steps are solving a linear equation in one variable. First and foremost, we need to simplify each side of the equation separately as much as possible. This is an essential step in solving equations. We're going to use the distributive property to clear parentheses, just like we saw in the warm-up, and then combine like terms. Now we want to, once we have both sides simplified, we want to isolate the variable part to one side of the equation and the constants to the other side of the equation. Doesn't matter which ones we pick for the variables and constants, but we want all the variables to one side, all the constants to the other. And then once we have the variable isolated, we use the multiplication property to get rid of any coefficients, and then the equation is solved. Once you find your answer, make sure to substitute that value back into the original equation to make sure it checks. First example. Five minus 2x equals 8x plus or minus 5. So we need to pick a side then for the variable parts. We either want to get all the variables to the right or all the variables to the left, and then the opposite for the constants. Well, I like to keep my coefficients on the variables positive. So we could subtract 8x from this side and 8x from this side, get -10 on this side. Then we have a negative coefficient of the variable. Then you can still solve it that way, but then you have to worry about keep track of your negatives. And it's just more ways to make mistakes. So might as well just keep them positive. So if instead we add 2x to both sides, we get a positive coefficient on the variable. Now, since we just moved all the x's to the right, we want to move all the numbers to the left. So we need to get rid of this 5. So we'll add 5 to both sides. So that gives us 10 equals 10x. Now the last thing we have to do is divide by the coefficient. Divide by 10, we get x equals 1. Now if we plug this back into the original equation, we got 2 times 1 here, so that's 2. 5 minus 2 is 3, so we get 3 on this side. Then over here, 8 times 1 is 8. 8 minus 5 is 3. 3 equals 3, that checks. Make sure you do that after every equation. Your turns, number 1 and 2. The first one, I'm going to subtract the smaller of the two. That'll keep the x term positive. So minus 2x minus 2x. Now if you like to, you could do 2 things on one step here. So I'm moving all the x's to the left. It means I want to move all the numbers to the right. So I can add 7 here and add 7 here. Notice I've got things all lined up nicely in columns. So I've got x terms over x terms, numbers over numbers. Equal sign is going to stay in its column there. X term constants. If you keep things organized like this, when things get more complex, you'll be able to keep things straight. All right, so that gives us 4x on this side equals 17, and 7 is 24. Divide by the coefficient, and x equals 6. Now if you go to number 2, we have a little different situation where both the x terms are negative. So in this case, I want to add the bigger of the two. So if I add the smaller of the two, if I only add 4 to each side, I'm still going to get negative 3x over here. Again, trying to avoid that negative coefficient. So instead, I'm going to add 7x here and 7x here. That's going to move all the x terms to the left, meaning we need to move all the numbers to the right. So I'm going to get rid of this 18, so I'll do the opposite there. Since it's positive 18, subtract 18 from each side. All right, those go away. Negative 4 plus 7 is 3, so we get positive 3x equals 6 minus 18 is negative 12. Divide by the coefficient on the x, and x equals negative 4. I'm not going to take the time to check those during this presentation, but make sure you do after every problem. Our next example, we got 10 minus x equals negative 2x plus 9. So I'm going to add 2x to both sides. That'll give us a positive x over here. So if you have 2 negatives, add the bigger one. That brings all the x's to the left, so I'm going to get rid of this number on the left so I can move all the numbers to the right. All right, those go away. Negative x plus 2x is single positive x. Those go away. 9 minus 10 is negative 1. We get x equals negative 1. Your turn number 3. So we've got 2 negative x terms here. So I'm going to add the larger one, plus 3x on both sides. That's going to move all the x terms to the right. Instead of all the x's over here, I want to get all the constants to the left. So minus 6 to get rid of that. Minus 6 over here. 4 minus 6 is negative 2. Equal sign stays right underneath the original. These go away. 6's go away. Negative 2x plus 3x is x. X equals negative 2. Now we're going to look at some equations that require simplifying before we do any of the properties. So 8x plus 3 minus 4x equals 2 plus x plus 4. Now, a big mistake that I see when working on an equation like this is, oh, we've got negative 4x, I want to get rid of that, so I'm going to go plus 4x here, and then I got another x term here, so I'll go plus 4x here, and plus 4x here. So everywhere you see an x, you put a 4x in there. So what's wrong with this? Well, here's our equal sign. Right? There's the middle of our balance, and we just added 4 to this side, and we just added 8 to this side. We just did different things to each side of the equation. Can't do that. Now our equation is unbalanced. So you can never add something different to one side of the equation that you do the other. So we're not going to do that. Instead, what we're going to do is simplify first. We're going to combine like terms on each side of the equation. Here we have 2x terms, so we're going to do 8x minus 4x gives us 4x. And then keep the 3, 4x plus 3 equals. And on this side we also have some like terms. We have the constants, 2 and 4. So we got x plus 6. All right, now we can use the properties. So I'm going to use the addition property now. Subtract x from this side, subtract x from this side. Since they're both positive, we'll subtract the smaller one. That'll keep the x term negative. And again, this isn't necessary, but it's very handy. Now I've got all the x's over to the left, so I'm going to get rid of the numbers and move all those over to the right. So 4x minus x is 3x. Bring down the equal sign straight down. Those go away. 6 minus 3 is 3. So we get 3x equals 3, divided by 3 on both sides, and x equals 1. Your turns, number 4 and 5. So number 4, we've got like terms here, 3x and 8x, that's 11x. And over here we got 3 minus 9, that's 7x minus 6. Now we've got positive x terms, so I'm going to subtract the smaller of the 2 minus 7x minus 7x. Get all the x's to the left, we want all the numbers to the right, so you can get rid of that positive 2 by subtracting it. 11x minus 7, that is 4x. Bring down the equal sign straight down. Negative 6 minus 2 is negative 8. Divide by the coefficient on the x. Divide by 4, we get x equals negative 2. Got like terms here. 2x minus 7x gives us negative 5x. And negative 8, that'll stay on the left-hand side. And over on the right, you got 2 minus 14, that's negative 12, minus 4x. I got lots of negatives here. So if I were to add 4x to each side, this one would still be negative over here. So I'm going to add the larger one. So plus 5x on this side, plus 5x on this side. That'll give us a positive x on this side. All right, get all the x's over here. I want to get all the numbers to the left. So we got negative 12. We do the opposite and add 12 to both sides. All right, the x terms go away here. Negative 8 plus 12 is 4. Equals, those go away. Negative 4x plus 5x is x. So x equals 4. Next example. So some equations will have more than one pair of like terms. Right here we've got x terms and we have constants. So I'll have to combine both of these on the left-hand side. 9x plus 4x is 13x. 6 minus 2 is 4. So 13x plus 4 equals, I get a couple x terms over here. 5x plus 7x is 12x. And plus 4. Now I can subtract 12x from each side. And we've got matching 4s on each side, so we can get rid of those. Minus 4, minus 4. 13x minus 12x is a single x equals, and over here, everything goes away. 12x minus 12x, those go away. 4 minus 4, that's all 0. So x equals 0. And this one's really easy to check, because when we plug in 0 for x, all the x terms go away. So this one's 0, this one's 0. We get 6 minus 2 is 4. That's 0, and we have 4 on the right as well. So 4 equals 4, and it checks. Your turn, number 6. Here's one pair of like terms on the left, 6x plus 7x, that's 13x. 5 plus 3 is 8. And on the right, we got 1 and 3 is 4, so that's 12x plus 4. We'll subtract 12x from each side. That'll give us a positive x term here. And then we're going to subtract 8 from each side. So these go away. 4 minus 8 is negative 4. So x equals negative 4. Now we're going to look at some equations that include some parentheses. So first thing we want to do here, before we start thinking about combining like terms, is distribute in to clear those parentheses away. Because then we'll know what our terms actually look like, and then we'll be able to combine like terms. So 3 times 1 is 3. 3 times negative x is negative 3x. Plus 11 equals 1 plus 2x plus 18. All right, so now all the terms have been revealed. Now we can start combining like terms. So we're going to keep this negative 3x. That's the only x term on the left, so that will stay as it is. And then we have 3 plus 11, 14. Now on the right side, we got one x term over here, that's 2x, and 1 plus 18 is 19. So 2x plus 19 on the right. Now I've got one negative and one positive, so I'm going to add 3x to both sides. That'll give us a positive 5x on the right. Now we're going to get all the x's to the right, so that means we need to get rid of the numbers on the right and bring them to the left. Minus 19 minus 19. So we got 5x here equals, and negative 5 here, everything else goes away. Divide by 5, divide by 5, we get x equals negative 1. All right, 4 practice problems. Your turn, 7, 8, 9, and 10. For turn number 7, we're going to start off with distribution. Distribute into these parentheses. Just remember, once you've distributed in, remove the parentheses. Next up, we're going to combine like terms. 4x plus 2x on the left gives us 6x plus 8. We have 3x plus 20. Got 2 positive x terms, so I'm going to subtract the smaller one. That'll give us a positive 3x on the left. Now we're going to move all the numbers to the right, so minus 8 here and minus 8. We've got 3x equals 12. Divide both sides by 3, and x equals 4. Now I've got some parentheses here. These look a little different because we just have the negative sign out front. This is just like if we had negative 1 here, and we could distribute negative 1 into those parentheses. So that gives us 8x minus 3x plus 4. So all we're doing is switching the signs on everything inside the parentheses. So 3x becomes negative 3x, negative 4 becomes positive 4. Equals 2x minus 5. Now we can combine these like terms. 8x minus 3x is 5x. We've got 2 positive x terms, so I'm going to subtract the smaller. That brings all the x's to the left, so I'm going to move all the numbers to the right by subtracting 4 there and 4 there. So we got 3x equals negative 9, divided by 3, and x equals negative 3. Now we've got two sets of parentheses, so we're going to do double distribution on the first step. So 2 minus 6 minus 18x equals 4x minus 4. Now we can combine like terms. We got a couple constants here on the left, so 2 minus 6 is negative 4. I'm going to add 18x to both sides, bring that over to the right, and looks like we have the same constant, so those are both going to go away when we add 4 to each side. Notice everything here goes away. So we have 0 equals 22x divided by 22. Anything 0 divided by anything is still 0, so x equals 0. So we'll start off by clearing these parentheses. We're going to distribute into this one. Gives us 4x minus 6x minus 15. Don't forget the 8 plus 8 there. And over here, we're starting with 12. Distributing negative 1 into these turns the 5 negative and the 2x positive. So switch the signs on both of those, plus 3x. Now we can combine like terms. Now that we have all the parentheses gone, the next step is always to combine any like terms that you see. So 4x minus 6x, that's negative 2x. Negative 15 plus 8 is negative 7. So 2x minus 7 on that side. And to the right, 12 minus 5 is positive 7. 2x plus 3x is 5x. So I've got a negative x term over here, positive over here, so I'm going to add 2x to both sides. Now we need to get the numbers to the left, so minus 7, so we got negative 14 equals 7x. Continuing on over here, negative 14 equals 7x, divided by 7 on both sides, and we get x equals negative 2. Now we're going to wrap up our study of equations with parentheses by looking at nested parentheses. Now we saw these with expressions, and we were working with expressions, simplifying them. We started with the inner parentheses and worked outward. So that's what we're going to do with equations as well. So here are the inner parentheses. We're going to remove these by distributing into them. Everything else in this thing is going to stay the same. So just copy it down. Now we'll distribute here. 2 times 4 is 8. 2 times 3x is 6x. Close the outer brackets now. And the other side stays 2x minus 4. All right, now let's combine like terms inside the parentheses. Simplify as much as possible before we distribute into them. This can be negative 3. Negative 5x plus 6x is a positive x, so x plus 8 on the inside of it. Now we can distribute in. Negative 3 times x is negative 3x. Negative 3 times 8 is negative 24. Now I'm going to add 3x to both sides. That brings all the x's to the right. Now we can get rid of this number here by doing the opposite. So plus 4 plus 4. So we got negative 20 equals 5x. Everything else goes away. Divided by 5 on both sides. And we get x equals negative 4. Your turn, number 11. So we're going to start by distributing into these inner parentheses first. So nothing is going to change out here. Only thing that will change is this distribution here. So 3x times 4x is 12x. 3 times negative 3 is negative 9. Now inside the parentheses, we've got a couple of like terms we can combine, the two constants. We'll do 4 minus 9. So we get 2 times 12x minus 5 equals 15x plus 17. Now that we have it fully simplified inside the parentheses, now let's distribute in. 24x minus 10 equals 15x plus 17. All right, now we've got two positive x terms. So I'm going to subtract the smaller of the two. Now it'll give us a positive x term over here. So 9x, and then we'll add 10 to both sides. 9x equals 27. Divide by 9 on both sides, and x equals 3. Up next, we've got some applications. First is the fixed cost for a business. The fixed cost is defined to be the number of units that a company has to sell so that no profit or loss occurs. In other words, the revenue coming in, their income, exactly equals the amount of money they're spending. The equation we're going to be using, Px equals Cx plus F. P is the selling price per unit. X is the number of units sold. C is the cost per unit. And F are the fixed costs. So let's look at what each of these means in the context of the first example. So we've got a candy maker determines that the cost per box of candy is $1.27. All right, so in this example, cost per unit, $1.27. That's how much it costs to make each box of candy. So that might be the ingredients, the packaging, stuff like that. Things that they need to pay for every box of candy that they make. Now the fixed costs are $837.64. So in this example, the fixed cost may be the machinery required to create the candy, or if they've got their own packaging, the machines required to box it up. Now we got the selling price per unit, that is $2.99. So we want to find the break-even point. So we're solving for X, the number of units we're selling. So we're going to plug all our known values into this equation. So that gives us $2.99. X equals cost per unit is $1.27, so 1.27 X plus 837.64. All right, now we've got an X term on each side, so I'm going to combine these. We're going to combine like terms. I'm going to do that by subtracting 1.27x from each side. So that gives us 1.72x equals 837.64. So 1.72, we got that by subtracting the cost from the selling price. So this is the amount of profit they make on every box. So we need to divide our fixed cost by the profit on every box. So divide by 1.72. We get 487. So to break even, they must sell 487 boxes. That brings us to your turn, number 12. Custom t-shirt maker. Cost per t-shirt is $4.28, and the fixed cost is $1,288.22. If the selling price of a t-shirt is $19.99, find the break-even point. So we'll plug in what we know. Selling price is $19.99, so we get 19.99x equals 428 per t-shirt in cost, so 4.28x, plus the fixed cost of 1,288.22. All right, we've got an x term on each side of the equation, so we can subtract here 4.28x from each side. That gives us 15.71x equals 1288.22. Now we'll divide both sides by the coefficient. Dividing it out, we get x equals 82. So to break even, they must sell 82 t-shirts. Now if they sell fewer than 82 t-shirts, they're going to lose money. If they sell more than 82 t-shirts, then they'll make money. And at 82, they exactly break even. All right, there's two more examples, two more your turns, one from physiology and one from financing. So read through them, take a look at the equation, figure out where to plug in what we know, and then solve for what we don't know. the first example, for a small mammal at rest, the oxygen consumption, C, in millimeters per minute is related to the animal's weight, m, in kilograms. And we've given the equation m equals 1/6 times c minus 5. So we're going to find the oxygen consumption for a mammal that weighs 26.7 kilograms. So the weight, that's m. So we put 26.7 in for m, and now we're going to solve for c. So we got 1/6 times c minus 5. So we've got this fraction that's multiplied by the entire right side, so we can get rid of that by multiplying both sides of the equation by 6. Then the 6 on top, 6 on the bottom cancel, and on the right we're left with just c minus 5. On the left, 6 times 26.7 gives us 160.2. Now we want to get c by itself, so last step is to get rid of that 5, or get rid of the negative 5 by adding 5. And we get c equals 165.2. So the oxygen consumption is 165.2 milliliters per minute. And now we're back to the introductory example. Suppose we're saving for a $2180 down payment on a vehicle. We have $750 saved so far, and you estimate you can save $65 per week. So we're going to let W represent the number of weeks. We'll write an equation to model this situation. So the total that we want is $2180. We're starting with $750. Now we're going to add on our savings per week. So if we're saving $65 per week, the amount of money we save weekly can be represented by 65 times W. $65 times the number of weeks. Now we can solve this for W and figure out how many weeks we need to save for. So subtracting 750 from each side, we get 1430 equals 65W. Divide by the coefficient, and W equals 22. So it will take 22 weeks of savings to purchase the vehicle. So we've seen examples from a bunch of different fields, but they all work the same way. We're all given an equation, given some known values, we need to be able to plug them in, and then solve for the unknown value. That's it for today. Have a great day.